Hey, Honors Chemistry. I wanted to go over some questions from worksheet number 3. Some of us were having a couple of struggles, and I think it's good and helpful to have a couple of examples. So I'm going to focus on question number 4 and all of these different parts. So it says, in figure 4, below, a graph shows a relationship between mass and volume, mass on the y-axis, volume on the x, for two substances. Use the graph to answer questions about these two substances. You have built a sample two-pan balance shown above. So I have this two-pan balance. What would happen to the balance if you put equal masses of A and B in the two pans? Now remember, a balance is there for mass. If I have two of the same masses, so for this first question, two of the same masses, right, A and B, two in the same masses, it would be balanced. Right? A pan or a balanced pan, it tries to get weight. So if they're both the same, well, not weight, but mass. It tries to get the same mass. So if they have the same mass, it's going to stay the same. All right? If it has the same or equal volumes, I'm going to say it depends. Why does it depend? It depends on the density. And you can clearly see that these two substances have different densities. So let's just say I was choosing the same volume. It doesn't matter which one I choose. Let's say I choose like 40 milliliters. Doesn't matter which one you choose. I'm going to draw a line all the way up where they hit the graphs of the lines here. I choose 40 milliliters for substance B. 40 milliliters is equal to 20 grams, and that's what the graph is showing me, right? I just kind of go over. For substance A, 40 milliliters gives me about, if I'm looking at this, I would say about 40 milliliters gives me about 64 grams. And I'm just estimating using my own error. If I have equal masses, it looks like more mass of A than B. And if that's true, if I have the same volume of A and B, that means it'll tip towards A. Okay, now and so I'm using the graph for that, but I could also calculate that. But basically, if I'm looking at the same volume of substance B and A, for B it shows me that it's 20 grams is 40 milliliters, and for A it shows me that 40 milliliters is 64 grams. All right, now it says find the slope of the lines for both A and B. Don't forget the units. State the physical meaning of the slope for each. Now you could choose any 2 points to do that y2 minus y1, right? So if I want to calculate the slope, I showed you in another video, I just sent it not too long ago, how to calculate the slope. Now if I'm choosing this point 0, 0 as like my y2 or y1 or so my x1 or x and y1, I could just do my mass over my volume. So if I want to do the slope for A, I could just do 64 grams over 40 milliliters. And if I do that calculation, if I do 64 over 40, I get about 1.6 grams per milliliter for A. And then, again, remember, density is mass over volume. So if I do it for B, if I do 20 grams over 40 milliliters, that's equal to 0.5 grams per milliliter. Okay? And so remember, density is a mass divided by volume ratio. It tells me how much mass I have per my unit of volume. And so what the physical meaning is, for every 1 milliliter of A, there are 1.6 grams of A. And I'm not going to write it, but for every 1 milliliter of B, there's 0.5 grams of B. A little bit more challenging, it says if you put 10 milliliters of A in one balance pan, what mass of B would you need in the other pan? Now remember, I need to have masses in these pans, not volumes. And if I want the pan to be balanced, make it balanced, I need to have equal masses of A and B. Well, if I have 10 milliliters of A, I want to convert milliliters of A to grams of A. Now there's two ways of doing this. I could look at the graph, or I could calculate this. So if I look at the graph, if I have 10 milliliters of A, here's 10. If I have 10 milliliters of A, if I'm just looking at the graph right here, 10 milliliters of A looks like it's about, maybe, from the graph, the point is about 16 grams. I'm just looking at the point. If I want to calculate it, remember, mass is equal to volume times the density. So my mass is going to be equal to my volume, which is 10 milliliters, times the density, which is 1.6 grams per milliliter, and I get 16 grams of A. And then, if I want the pan to be balanced, I would need an equal mass of B to be balanced, so 16 grams of B. Some of you might have got 15, some of you might have got 1 point, or 15.5 or 16.5. It all has to do with how you read the graph. D is a little bit more trickier. There's a couple of parts here. It says if I have 35 milliliters of B, what volume of A would you need to balance? Now remember, for the balance, I need a mass. So I'm going to have to convert my volume of B to a mass of B. And I'm just going to calculate it, right? Mass is equal to volume times the density. So my volume is 35 milliliters. My density is 0.5 grams per milliliter, because this is of B. Volume of B, density of B. And remember, the density of B is 0.5. 35 times 0.5 is 17.5 grams of B, right? Milliliters cancels out, and I'm left with grams. Now, in order for this to be balanced, I must have the same mass of A. So I need 17.5 grams of A, right, in order for that to be balanced. But does the question ask me for the mass of A? It doesn't. It wants the volume of A. To go from grams of A to volume or milliliters of A, I could either look on the graph or I could calculate this. If I have 17.5 grams of A, if I look on the graph, I'm probably at about maybe 10 or 11 milliliters, okay? And that's like kind of like up here. If I want to calculate this, mass divided by density is equal to volume. So if I do 17.5 grams divided by 1.6 grams per milliliter, I will get about 10.9 milliliters of A. And it makes sense because substance A is more dense. The slope, which is equal to the density, is 1.6 grams per milliliter, and this density or slope is equal to 0.5 grams per milliliter. You could also just look at this graph and see that substance A's graph, like its line, is more steep. If it's more steep, like it's like on an incline, it's like really steep, like going up a steep hill, it's more dense. And then substance B is less steep, so it's less dense. And then for letter E, it says water has a density of 1 gram per milliliter. Sketch that line. That means for every 1 milliliter, there is 1 gram of water. Well, that means my mass is equal to my volume there. For every 1 milliliter, I have 1 gram. So if I have 10 milliliters, I have 10 grams. If I have 20 milliliters, I have 20 grams. I could begin to plot that here. 20 milliliters, 20 grams. 30 milliliters, 30 grams. 40 milliliters, 40 grams. 50 milliliters, 50 grams. And I could sketch that graph, and here's my water graph. And it looks like my density of water is less than A, but greater than B. Or my substance B's density is less than water, and my substance A's density is greater than water. So in answering letter F, it says determine whether substance A or B will sink. I'm going to tell you that if something is more dense than something else, if something is more dense than water, it's going to sink. Substance A has a graph that's higher than water. It's more dense. It's going to sink. Right? And so graph is higher than water. So it's going to sink. For substance B, the graph is lower than the graph of water, so that's going to float. Graph is lower than water. So that is how we'll answer this question. And from now on, if I see density graphs, if I see a line that's higher, it means it's more dense than a line that's lower, which is less dense. And then usually if I draw my line for water, if it's above the line for water, it's going to sink in water. And if it's below the line for water, it's going to float in water. It means it's less dense. So this was a complete explanation for question 4. Question 4 had a lot going on. Let me know if you have any other questions, comments, or concerns about worksheet number 3. I will probably think about making a video on the next 2 questions on this worksheet.